Well, well, well. What do we have here? It's one of those cheap, crappy air compressors from Harbor Freight that I never thought I'd actually own. However, one day I was having a spontaneous brainstorm and we got an idea. This 3-gallon oilless air compressor is not going to be oilless for long. I had a coupon. I think it was $30 or $35. And one thing that we're never too short on around here is old chainsaws. If we could just combine the two. So that got the old wheels turning. I need to figure out a way to get a chainsaw to run this thing. That way when you don't have access to power or a generator, you can still have compressed air. Now I know that they actually make, real gasoline powered air compressors, but I'm not about spending $500 to $1,000 for something like that. And this is going to be a good brain exercise, figuring out how to make parts work together that never should. So I bought this like 3 months ago, figuring I was going to get started on this project, right away. As usual, procrastination takes over. So this thing is now outside of its standard 30-day warranty. Because of course, you don't purchase the extra warranty on something like this. So there's a pretty good chance this thing's going to die on the first time we run it. And we're just going to be out of luck. That little thing's kind of cool. We'll see if it's more than just a paperweight. These directions ought to make good fire starter. Well, I don't know who I'm kidding about the warranty anyways. We're going to start hacking this thing up immediately. You could say I'm pretty pumped about the prospect of this actually working. Well, that's more like it. So we are going to at least run this thing briefly in its current form to make sure it sort of works. I'm sure it's only the finest of Chinesium. It's definitely not a powerhouse. I guess we'll see what happens. That safety guarding's been on there for way too long. Well, there's the guts of it. That whole unit's a lot smaller than I was expecting. Kind of thought a 3rd horsepower compressor would be bigger than that, but... So the basic plan of attack is to essentially replace this electric motor with a gas-powered one. Whether it be by removing the pump here and putting a sprocket on there, or just throwing a sprocket onto the end of the existing electric motor here and just kind of using this as a drive shaft. The other thing that we were counting on for an air compressor was a traditional pressure switch. These type of switches have a actual mechanical contact that flips over and snaps back when you hit certain pressures, and that's what connects and disconnects the electrical power to the motor. We're going to use that, physical movement of the contactor to run the throttle on the chainsaw. So if we're going to use this air compressor, we're going to have to add one of those. So hindsight's 20/20, but my sight isn't. So we're going to continue on with this thing and make it work somehow. Probably better off if you were to start with maybe a slightly larger air compressor motor. I mean, heck, you'd have a bigger tank and everything, but your wallet would be a bit smaller with what you got to spend. So you can make that choice. So we got this neat little bugger, which is keeping with the Chinesium theme. It's a laser tachometer. You got the reflective tape there on the cooling fan. And we're going to fire it up and see what kind of speed that motor's turning. Wow. Well, that's a whole lot faster than I was expecting. On a bigger motor, I was figuring we were going to need quite a gear reduction from the chainsaw for the pump motor. Usually I figured these things would be spinning around 1,000 RPM max. So the chainsaw running at 8,000 or so, give or take, you're going to need roughly a 10-to-1 reduction from the chainsaw to your compressor pump. Don't worry about your warranty. I mean, they wouldn't let you take these apart if they didn't want you to, right? So we're going to pretty much gut most of the electrical stuff on here for now. I mean, maybe save the motor casing here just in case we need to use it as a, an idler bearing support or something like that. But for the most part, this stuff's pretty much gone. Which is good because mechanical systems always trump electrical systems. So we've got the business end here, and upon further inspection, we actually have a little set screw down in there that I suspect is holding on, this motor shaft. And that hole right there, which acts as the air intake, is also an access port for when you roll around to that set screw. Well, of course, that set screw is like Loctited in there and we can't get it out. But my ideas are quickly shifting here on how we're going to put this thing together. Essentially, this compressor end right here, we could bolt this right onto the chainsaw bar. And if we could get a pulley, onto that shaft, or, I don't know, directly onto that rotor there or whatever, we'd be in business. Well, a little bit of the blue wrench, and it looks like we got it started. So with the help of the air hammer, we successfully disassembled the motor and air compressor. So between the saw and the vise, we were able to extract this piece of shafting here. So since this end of the shaft here is also cut for a set screw, we're going to insert this back through that bearing there, which is going to go over into the crankshaft here, like that. And then we'll have two bearings, one here and one here in the housing. And that'll give us some support for when we put the sprocket on there, and it'll be able to spin it. Now it's important that you get to this stage of the build quickly, because it ensures that you're so far in that you've destroyed everything, and that the only way to salvage it is to finish it. So for the choice of chainsaw, we've either got this old Poulan, or we've got that Craftsman. Now these were both free chainsaws, so the price was right. But what's not right is that both of them kind of have some weak compression to them. Now the Poulan is unknown since I just got that and I really haven't done anything with it. However, the Sears, I picked this up a long time ago. It was a freebie and I was able to get it running. Probably had to clean the carb and stuff. And at one point in time, had a pretty big maple tree I had to cut up, probably 40 inches in diameter or so. And this thing has a 20-inch bar, which was the biggest saw that I had running at the time. And we tried to go to town on it with this. We put her to work, and about 3/4 of the way through getting through that pretty big log, she started getting kind of doggy and started losing power. So we shut it down, and as it turns out, the compression was pretty low. I pulled the muffler off, and you can see some scoring on the pistons, so she kind of got cooked a little bit. But we're not giving up yet. I'm sure you could probably take this thing apart, Scotch-Brite that piston up, clean it up, get the rings unstuck, and she'll probably keep going. And compared to the size of this air compressor, we really don't need a whole lot of chainsaw. So we've been thinking about how we're going to drive that compressor. And initially I thought I was going to use like a bicycle chain or something along those lines. And we could just modify this clutch and put that type of sprocket on here. Sort of like I did on the chainsaw chop saw modification, where we put a belt drive instead of the chain drive. However, I'm feeling kind of lazy on this one, so we may end up just using the actual chainsaw chain as the drive chain. And we don't even have to mess with the clutch on the chainsaw. Now, believe it or not, they don't sell conversion sprockets to go from a chainsaw chain to a mechanical drive. However, don't let that stop you. Went through the randoms pile and I found some of these big washers. I mean, these are dirt cheap for, a prefabricate for a prefabricated ring. So we got some random steel, galvanized sheeting out of the scrap pile. And we chopped this little slug out here. Now this metal is the same thickness as the little drive teeth on that chain. So we're going to take the washer, sandwich the slug in the center here, cut a bunch of teeth in it to match the pitch of the chain, and then we'll throw the other washer right on top, weld everything together, and punch a hole through the center, and there we go. There's our drive sprocket. And we can mount that directly to this shaft right here. So how do you machine, a circular disc like that to a specific size when you don't have a lathe or a machine? So we marked out how the chain would sit onto the washer here. We're going to transfer this, which is 14 teeth, over to the washer and then cut the notches into it. Well, that was slightly painful, cutting this out on the bandsaw, but we've got a nice throwing star here, and we're going to use that as the sprocket, hopefully, or we're going to grind it till it fits, or, well, we'll see. So after we, clamp everything together and weld it, that'll be our drive sprocket. I mean, it's not perfect, but that ain't bad. So we were going to, chop up the chainsaw bar here to be the mounting surface for the, compressor base. But I forgot, this is like hardened steel. It's hard to saw through this stuff, let alone try and drill through it. So we picked up some scrap from outside and, we're making a surrogate bar here to mount that base onto. Now I would have never guessed this, but, I don't think the centering tolerances are very tight on these washers. But we can fix that when we weld on this nut here, which is going to be the sleeve sort of that, gets welded onto the shaft here. So we got this washer here that's going to be our bearing retainer. It'll fit sort of like that. And we'll just bolt this through to there with some spacers in between. I really like how they call this thing an oilless compressor, even though there was a bunch of grease smeared around the piston and the ring and stuff upon, initial installation. So, yeah, it's just non-serviceable. So the sprocket's starting to come together. We got our little drill bit stop, / locking collar on there. We'll eventually have to finish welding that up completely. And we'll just grind a flat on the shaft there for that set screw to sit on. And that should hopefully, lock that onto the shaft. This isn't like a really high torque situation here, so I think we should be fine. Here's where things are starting to come together now, alright? So we've got our air compressor base mounted out here. You've got the sprocket that we're eventually going to attach to that shaft. This is our surrogate chain bar. And the beauty of using a chainsaw for this is that you actually have a clutch, already here. And the key to this whole build is that you can let the chainsaw idle, okay, when it's at low RPMs and you're not driving the compressor. However, whenever you need to compress air, you can just open the throttle, this thing will kick in the gear, and off you go pumping air. And that's where an old pressure switch is really going to come into play. We need this pressure switch because it flips back and forth, from two hard positions, to have the idle position at the carburetor, and whenever the pressure drops low enough and it flips into the, run mode, it's going to, hit that carburetor over into full throttle, spool up the clutch, start pumping air. Once we hit 100 psi, this thing flips back, idles the saw down, and we're just sitting there ready to go again. So here's a little bit of a rundown on how one of those pressure switches actually work inside. So you've got your whole case of the body here, and you have your air pressure that's coming in from the manifold, and there's a rubber diaphragm here that's held down by that metal casing on the top, and it's got a spring with an adjustment screw mounted above it like that. So this spring is adjusted with a preload to hold this diaphragm and stuff here and this plunger all the way down,
until you start getting into, like, the 80, 90 psi range. And at 90 psi, this thing starts moving upwards. At maybe, mid-range 110, you're somewhere in here. And at 120, it's all the way moved up to the farthest top it's going to go. Now, on the other side here, you've got a little structure and an arm, and that houses the contact arms. Now, the pivot point of that contact is right in the center of the stroke for that plunger. And connecting the two, there's a spring. It's got two little tangs on the end. It goes up, coils around in the middle, and back down with another tang. Now, that spring there, it takes up the distance between the two as it gets further and closer together. Now, at 90 psi, when the plunger's all the way at the bottom, it's down below the pivot point of the contact arm. So when it falls down to here, the spring starts pushing up on the arm, and it flips it up into the run position. Now, as the plunger starts moving up as your compressor's running, eventually, that plunger arm, the center of that, gets higher than the end of the contact arm pivot point. So when this moves up to here, all of a sudden now the spring flips it back down and it snaps into the off position. And you start all over again as the air pressure decreases. Now this lets you get two defined points of travel on this contactor here versus a slow movement throughout the whole pressure range.
Well, maybe it's time to actually start looking at the saw, We're getting pretty far along with this build, and, the power plant of it is still kind of unknown. I mean, yeah, it might have low compression and, a questionable carburetor, but, I think we can get it running. I mean, I bet you we clean that carb a little bit, and we'll be good to go. And we've got the little throttle rod here. We kind of straightened it out a bit, but this is what pushes and opens the throttle. So we're going to put that guide rod onto the little pressure switch thing there, and we'll just slap this thing right on here, hook that up on the here, and bam, there's our automated throttle control. That's a whole lot of stink bugs. Oh, forgot the carb boot. So in the process of taking the carb boot off, we moved a cylinder. I don't think that's supposed to be like that. The piston's not quite as bad as I was expecting. I mean, it's definitely seen some things, but I'd say that's salvageable. Good thing we took it apart and found that ripped carb boot, because we would have just ran it and probably exploded it. The cylinder's not in, terrible shape. A little bit of Scotch-Brite and that should come right back. Boy, look at how much that carbon has plugged up the exhaust. And of course the base gasket didn't survive. So at this point I guess we're into a full-on chainsaw rebuild. Now the base gasket is kind of trash. It was brittle. We tried to reuse it, but to no avail. So now we need to make our own. And I don't have the thin gasket material, about 18,000th that this uses. No luck in the gasket pile. However, we did find that the cardboard on the back side of the gasket containers, that ought to work perfect. See, this is really high grade, very nice paper, not your standard beer case. And a couple of minutes with a razor and there you go. That looks good as factory to me. I mean, tell me that doesn't look OEM. I can't believe it, but I did have to break down and buy a new part for this thing. But unfortunately, the old weather strip adhesive down there, that just wasn't going to cut it on this repair. Gave the cylinder a thorough rebuild with some Scotch-Brite pads. Well, a lot of uninteresting cursing and mumbling went on getting that cylinder back in there. So we're getting to that stage of the project where you even start questioning yourself, why the heck are we doing this? And this project in particular is basically just to see if we can. Had this idea of a gas-powered air compressor, which of course they make those. They're usually a bigger four cycle engine, 5-10 gallon air compressor tank. And last but not least, they're like $800. And they're also kind of overkill for what this is, the intent of this project. Something really small, light, and portable, that you have, with a gasoline source, unlimited amount of air. So when you think to yourself, man, I think there's a way to do that. Well, by golly, why not try and do it? Now this project is definitely turning into be more involved than I was anticipating, and probably afterwards will be a lot of lessons learned and maybe different routes or different parts or equipment I could start out with to make life easier. But what's the fun in that? So we're going to persevere and keep going and make something out of this pile of parts. I mean, your brain always needs a challenge, and it's not just absorbing all that beer. Sometimes you got to come up with some crazy ideas and actually try and figure out how to make them come to life. Well, I don't think there's supposed to be that much sawdust in the carburetor. So while giving the carburetor, its compressed air bath, we ended up blowing the little screen out of there. But we got lucky this time. We actually found it. That doesn't happen often. And another stroke of luck, the diaphragms actually seem to be fairly soft and pliable. We're just bathing them in some PB Blaster to try and revive them a bit more. So we recalibrated the throttle plate spring down in there, so it takes a lot less pressure now to push this to get it to wide open throttle. You can't even look at a chainsaw these days without completely rebuilding the fuel system. So we took the chainsaw chain and we hacked it apart and reconnected it in the length that we need. And because safety is first on this project, we actually ground down all the chisels and rakers on this thing. Well, things are kind of coming together. We got the air compressor base, sort of bolted on there. And we got the chain drive system kind of worked out. The carburetor's back together. And we have the, really safe ignition system hooked up again. It probably wouldn't be a bad idea to actually try and get this thing running first, before we go through all the anguish of actually mounting it on the compressor. Well, see if we can get it running. Now I kind of got to watch the throttle because it's kind of sensitive. Almost too easy. Well, we have the bar modification there sort of wrapped up. Had to do some grinding on the chain, to get those teeth to kind of work with that. We weren't 100% accurate on the pitch diameter spacing, so it's close enough. Had to throw a few extra washers in there to get the chain alignment right, so we don't quite have full bar adjustment, but you can just loosen them up and move the bar and tighten it as necessary. Now the throttle control system is sort of mocked up in place. Wow, who am I kidding? It's pretty much permanent as long as it doesn't fall apart. I mean, we did use 2 zip ties on this thing. Now you can see the throttle linkage there. Runs down and it's kind of wedged in between those 2 little arms there. Now when the air pressure hits 100, this little lever is going to flip down like that, and when it moves, the throttle will return to idle, and whenever it hits the low pressure, it'll pop itself open like that. Well, the zip ties are kind of moving. We might have to put a third one on. Yeah, as you can see, we use only the finest of construction materials. Since this saw was already pretty much trashed, we're not going to worry about an air filter. You know, that little bit of dust will help, you know, reseat those rings in there. So we've got things temporarily mocked up, you know, with a hose clamp. You know, we'll permanently attach this with another hose clamp, you know, when we're finished here. Oh man, finished off that Teflon tape. That's the end of an era. Now we're going to run an air line from the compressor head here over to this inlet right here. And we'll use this as a, you know, manifold to have this be the exit and go over into the tank. Since we plugged, you know, that other inlet there, we won't need to use it. And since we don't want to actually get a special T, you know, for this function, we're just going to use this because it's got it built in. I mean, I'm still slightly concerned about the reliability of using a chainsaw chain as a means of power transmission. I mean, it might not have been designed for that. So we're putting the air compressor back together. So even though this is an oil-free compressor, it still had grease on all the walls. So we're gonna, you know, cover up this thing here, you know, with the supplied plate that was on there. And there's a little intake hole down at the bottom where the air comes in. I'm sure we'll give that a hit of WD-40 or some oil every so often, you know, try and make this thing last a little while longer. So we put a few more tack welds around on here and got the flat on the drive shaft to help, you know, when that set screw strips out, we'll have something else here to keep this from spinning on there. So I thought I had some extra air compressor lines laying around. Turns out they're all dry rotted. So I hate to use it, but I have some transmission oil cooler line here. It's good for 400 psi. This ought to be plenty. We can't use a regular 1/4 inch line because it's only rated for like 50 psi. I'm sure it'll blow out with the amount of heat that you're getting from that, you know, the compression. So it might not be the cleanest of layouts, you know, but it is what it is. I mean, I could have put a 90 coming out of here, you know, to make the hose run a little bit cleaner. But I got a 5-pack of these hose barbs really cheap. So I'm not buying another fitting. I ain't paying for that. Well, here's a bonus. I was totally not expecting this air filter to still fit on there, but it's like it was factory. Forgot to put this little heat shield in here behind the muffler, so we get to reinstall that. So we gave up on the proper hose clamp retention and just went with another zip tie. And she's starting to look like an air compressor. I mean, now there is, you know, an all-night Judas Priest marathon going on, but I don't think the neighbors would appreciate this thing firing up at midnight, so we're going to have to wait till tomorrow. Alright, we'll see what happens. If we can figure out which way the kill switch works. Okay, maybe for the test run we're going to jam a nail into the throttle, keep it from going wide open. That ought to do it. So we had to adjust the throttle a little bit to get it to idle.
So apparently we lost a nut in the process of the test run, and things got a little bit loose. I'm also not digging the way the exhaust is aimed right towards here. So we've got a proper popsicle stick in there this time. I was wondering what was flying out of there. Just a bunch of stink bugs. Alright, one rolling modification. There was a check valve underneath this inlet, and to get the back pressure out to the gauge to actually shut the chainsaw off, we always need this air coming back out of here. Well, there it is. It does work. So that's a victory. I think we might put on an extra set of zip ties here to make things a bit more permanent, you know. I think we got the idle range locked down on where we want the pressure switch. One problem that I do see from the amount of metal shavings on the chain, that sprocket, that's definitely the softest of the all the steel pieces, and it's going to wear out first. So we're going to have to get back in there and either weld up them teeth to give it a hard face, or, you know, beef up that sprocket. Honestly, if you're going to do this, you should probably just get a junk bicycle and go to a roller chain. This was a lot of hassle trying to reuse this as a drive chain, so don't do it. Maybe I can change your mind. But it works, as long as you keep your standards low and your spirits high.